For this example, we have, for the pair of functions defined, find f plus g, f minus g, f times g, and f divided by g. Give the domain of each. So our functions, f of x equals x squared minus 4, and g of x equals 3x plus 9. First thing we want to find is f plus g. So the name is exactly how we do it, how we construct it. F plus g of x is the same thing as f of x plus g of x. And f of x is x squared minus 4, and I want to add that to 3x plus 9. Then we want to simplify by combining like terms. That would give me x squared plus 3x plus 5. So f plus g is x squared plus 3x plus 5. Then it says, find the domain of f plus g. So we need to go back a little bit and first think about what is the domain of these individual functions. So for f is x squared minus 4, and x squared minus 4 is a polynomial function. So that's going to have a domain of negative infinity to infinity. And g of x equal 3x plus 9 is also a polynomial function, and it'll have a domain of negative infinity to infinity. When you take two polynomial functions and add them together, it creates another polynomial function, which has a domain of all real numbers, or negative infinity to infinity. So that is the answer for domain of f plus g, negative infinity to infinity. So moving on to the next part, we want to find f minus g of x. F minus g of x is f of x minus g of x. F of x is x squared minus 4. And I want to subtract g of x. Notice I'm putting parentheses around g of x to make sure I'm subtracting the whole function. And when I simplify this, I need to distribute that negative sign. Make it minus 3x minus 9, and then combine like terms. That would give me x squared minus 3x minus 13. So that is f minus g. And then we want to find the domain of f minus g. So just like the previous example, when you take two polynomial functions and you subtract them, you're going to create a new polynomial function. So the domain of that function will be negative infinity to infinity as well. The next part is f times g of x. Well, f times g of x is the same thing as f of x times g of x. So that's going to be x squared minus 4 times 3x plus 9. Notice I put parentheses around both of those because I want to multiply the whole function f times the whole function g. And now we're going to multiply that out with the FOIL method, or if you have another method of multiplying you like, you can do it that way. So that would give me 3x cubed plus 9x squared minus 12x minus 36. There are no like terms there, so this is as far as we can go. On the next part, we want to find the domain of f times g. Just like the previous examples, when you take two polynomial functions and you multiply them, that's going to create a new polynomial function, and the domain is negative infinity to infinity are all real numbers. The next part, f over g of x. F over g of x is the same thing as f of x over g of x. So I'm going to have x squared minus 4 in the numerator and 3x plus 9 in the denominator. When you simplify expressions like this is a rational expression, you want to factor and see if there are any common factors that you would cancel out. Your numerator here can factor, it's a difference of squares, x plus 2x minus 2. Your denominator, both of these terms have a common 3, so I can factor out a greatest common factor of 3. So we get 3 times x plus 3, and I notice that there are not any common factors, so this is as far as you would need to go. It is in lowest terms or simplest form. The next part says find the domain of f over g. So this one is different than the previous examples. In all three previous examples, adding, subtracting, and multiplying created another polynomial function. But when you divide two polynomials, you don't create a polynomial function, you create a rational function. With rational functions, we're worried about the denominator being 0. So to find the domain, we're going to take that denominator of 3x plus 9, set it equal to 0, and solve. So we're subtracting 9 on both sides, we get 3x equals 9. 3x equals 9, we'll divide by 3 on both sides and get x is equal to 3. The value of x equals 3 is going to cause the denominator to equal 0, and when you divide by 0, that's something that's undefined. So we don't want the value of 3 in our domain. It has to be excluded from the domain. So if we're thinking on our number line, we would mark 3 on our number line. That value is excluded, which is why I wrote it with an open circle, but we're going to include every other number on the number line. So using this picture, we can draw the interval notation. I want to draw an interval for the left side here, the shaded region on the left side. That goes from negative infinity to 3. And I want to write an interval for the right-hand side, the shaded region. That goes from 3 to infinity. And I'll put the union sign between those two. So that's our domain of f over g. Negative infinity to 3, union with 3 to infinity. Thank you for checking out my videos. Have a great day.